Server-rendered front-end applications can be created using ASP.NET Core using two different patterns. As we go through all available ways to create applications in ASP.NET Core, you'll see the code for an application created with each technology. So in the GitHub repository, you'll find the same application multiple times, created with the different application options ASP.NET Core brings. It is the carved rock application, showing all product specials. It also has the ability to add a product to the list by clicking on a link. After the new product is submitted, it will show the starting page again with the new product added. Object of the product class will be used to carry product data. But you might notice something that stands out here. There are attributes applied to the properties. They are called data annotations, and they are used by ASP.NET Core to do validation. We won't accept an empty name, for example. A name can't have more than 50 characters, and price can't be negative. We'll see how these validation rules are handled shortly. The photo file name property is used to simply point to an image present in the www root folder. In that folder is also the Bootstrap CSS framework, which I've used to lay out the pages. Product repository is a class responsible for getting the product instances. Normally, these kinds of classes will access a data store, such as a SQL database, to get the data, taking care of the conversion between what it gets from the data store and the product class. However, since accessing data stores may distract you from the goal of this course, I'm using in-memory data. Product repository has a corresponding interface. For each application, I've registered this class in the dependency injection container. This line of code means whenever there's an ask for iProduct repository, provide an instance of product repository. We'll see how we can ask for the instance soon. Notice that we're using a singleton lifetime to register the type. It means that only one instance will be created by the dependency injection container for the total running time of the application. Other options are transient, to create a new instance every time there's an ask, and scoped, to create an instance per incoming request. Notice that for an in-memory data store like this, singleton is fine, but when there are external dependencies to a database, for example, the scoped lifetime is probably a better option in order to have better concurrency support. Before I actually show you an implementation of the application, we're still missing the explanation of what server-rendered front-end applications are. I'm getting to that in the next clip. In the front-end box on this slide, I left a little bit of space between MVC and Razor pages and Blazor. That is because Blazor is different than the other two. Blazor enables us to create client-rendered front-end applications, which is the topic for another module. With MVC and Razor pages, we can create server-rendered front-end applications. But what is a server-rendered front-end application exactly? Here's an overview. Web applications have two important parts in play, the browser and the server. With server-rendered front-ends, the server does all the heavy lifting. When the browser does a GET request to the server with the intention to fetch an HTML page, the server processes the request. Typical processing would involve getting data from the database and rendering that in a web page using Razor. When the server is done processing, it will send the response to the browser. This response will be the page in pure HTML and CSS. Now let's say there's a link in the page that the user presses. In this example, the link to the About page. This will trigger a new request to the server, which will produce new HTML output, which is again rendered by the browser. In another scenario, The current HTML displayed in the browser could be a form. Now a post request is done when the user presses the submit button in the form. The post request will be to a certain URL, but this time the form data is attached. Maybe the attachment is a new product for Carved Rock. The server will take the attachment and process it. Add the product to the database, for example. When it's done processing, it will return HTML again as a response. This HTML page could be a list of products, showing the newly added product, or something that shows a thank you for submitting the product message. Razor Pages and MVC use different application patterns, two different ways to organize the code around the processing done on the server. Let me show you what I mean by looking at Razor Pages first. With Razor Pages, the routing mechanism of ASP.NET Core takes the URL it receives and maps it to something called a Razor page, which unsurprisingly is a page written using the Razor syntax. In this example, the /index after carvedrock.com is interpreted as a request for a page named index. The server will do everything needed to render the page and deliver the HTML to the browser. There's something special about a page called index. It is the default page, so when just the bare URL is used, Razor Pages will render the index page. Let me show you. No /index behind the URL, but the index page shows. Adding index to the URL shows the same page. We're taking a look at the location of the index page in the project. It is under a folder called Pages, and it has the extension CS_HTML. Take a look at this Razor syntax. It's just a part of a complete HTML page. We're missing the outer HTML tags as well as the carved logo, for example. That's because this page uses a layout page. Under the shared folder, there's an _layout.cs_HTML file, which contains the surrounding HTML structure. Our index page is rendered in the spot where it says Add Render Body. By default, all pages will use this same layout page, which saves us from entering the same markup over and over again. Back to the index Razor page. The first line makes this a Razor page, and there's a model declared. The object is referred to in Razor as just model. It is used to render the products with the C# for each statement, iterating over a property on the object called products. Now where is the model coming from? When I click the little triangle in front of index.cs_HTML, index.cs_HTML.cs appears, which contains the index model class deriving from the page model base class provided by the Razor Pages framework. Index model has the products property we saw referenced just now in the index.cs_HTML, and there's a method onGet that fills it with all products by calling a method onProductRepository, which is injected by the dependency injection container. OnGet is called a handler method. It will be executed when the page receives a GET request. And there's another interesting thing in the Razor I want to show you. There's an anchor tag that has an attribute called ASP-page. That's not a standard HTML attribute. This is an example of a tag helper. This attribute is processed by ASP.NET Core when it renders the page, just like the embedded C#. ASP-page takes the name of a page and turns it into a URL, which is then rendered in the href attribute of the anchor tag. So this will generate a link to the create page. Let's take a look at the create page now. It contains an HTML form that generates a post request. There's nothing special about the form itself except for the fact that tag helpers are used. ASP Validation Summary will display a list of all validation errors as soon as they are present. And ASP4, present on both the labels and the inputs, references a property in the model called NewProduct. Here's the model with the NewProduct property. It is decorated with a bind property attribute. This means as soon as the form is posted, this object will be automatically filled with the posted values. This is called data binding, and here's how it works. The input elements with the ASP4 tag helpers in the Razor I showed you will look like this when the HTML is sent to the browser. The name of the input is newproduct.name and newproduct.price, and both inputs have a value. When the form is posted, ASP.NET Core will now try to bind the values to an object with a bind property attribute that has the name specified in the input's name before the dot. In this case, we have a match, and after that it will look for a property on the object that is specified after the dot. Since the product class has a name and the price property, the property values in the object will automatically get their values from the posted data. Returning to the model class, it also has a handler method, but this time the method will be triggered when a post request is received when the form is posted. In it, we just tell the product repository to add new product. Nothing more is needed because new product will now be filled with the posted data automatically. But there's more in onPost. Model state is valid will check if there are any validation errors. The data annotation attributes I showed you earlier will be used to validate the incoming data. When there is a validation error, in other words, the model state is not valid, we return an object that comes from a call to the page method. This is an object that implements the iActionResult interface, the return type of onPost. This object will make sure that the current page, in this case the create page, is redisplayed. But since there are now validation errors, the validation summary will show. Let me show you. Let's leave the name value empty. Because the required attribute is present on the name property of product, the model state will not be valid. The same page is displayed, but now the validation error shows. When there are no validation errors, after adding the product to the repository, a redirect to page object is returned, which also implements iActionResult. This will redirect to the page specified, in this case the index, which will display the list of products again. MVC uses the same principles as Razor Pages, but there are differences, and we'll investigate these next.